Good afternoon, students. Hope you are doing good. Today, let's discuss a priori algorithm with some examples, which is one of the popular algorithm used to mine association rule from the large data sets. It is a part of module 3. So, to mine the association rules, we have two-step approach. In that, first step is to find the frequent item set or frequent item set generation. And the second step is to generate the rules, association rules. So how we find the frequent item set? As we discussed in the previous class, to find the frequent item set, one condition we have to follow, okay? That is, we need to use one of the metric, okay? That metric we called as a support. So in association rule mining, we have metrics or a criteria that we discussed in the last class. What are that criteria? Support, confidence, and lift. Okay. So here to find the frequent item set, we will be using a metric called support. So using this metric support, how we can find the item set is a frequent item set? By using this condition that the support of item set should be greater than or equal to the minimum support threshold. There will be minimum support threshold fixed. Okay. If the item set is having the support more than that minimum support threshold, then we can say that item set is a frequent item set. Hope it is clear for you. The next, once we find all the frequent item set, by using the frequent item set and another metric called confidence, we can generate the association rules. Okay. As I have told, association rule will be in the form of if then. Okay. It will be in the form of if then. If then. It will be in the form of if then. What is this if then implies? To find this rule, we have used the metric called confidence. So what is this if then rule? If a customer buys a bread, there's a chance that the customer also buys a butter. Okay, so bread and butter are the two item set which goes together. Okay, they have a correlations among them. Okay, so to say one standard example, it is a standard example. Actually, that is the main example it is considered. So if a person or if a customer buys a beer, okay, beer, okay, if the customer buys a beer, then the customer also buys the diaper. That means a person who has come to buy the items, okay, from the market or the supermarket like Walmart, Big Bazaar and all, okay, if he buys beer, okay, then if he have a baby, then he also go for the diaper. So there is a correlation with them. How they have identified? They have identified by using a metric called confidence. Okay. So, and before finding this, they have find out that it is a frequent item set or not. Okay. So using the confidence. So the confidence of this rule should be more than the minimum confidence. Okay. So here, out of these two steps, the first step, that is frequent item set generation, is very computationally expensive. Okay, I'll tell you why in the coming slide. Yeah. So before a priori algorithm, algorithm was used, which was using an approach called brute force approach. Okay, in which each item set was considered as a candidate. I showed you the item set lattice. Okay, so each item set is a candidate. It will be considered as a candidate. So when we consider each item set in the lattice and we count the support, here what we do here, each item set in the lattice will be considered, and the count of support of each candidate will be scanned by the data, scanned from the database. So here I'll show you. So let us consider this item set lattice. Okay, so as I told, if there is a d number of items, then there will be always 2 to the power of d possible candidate item set. Let us consider an example. Suppose we have 5 item set, a 5 item set. That is, item set is nothing but a collection of items. So when I say 5 item set, it is nothing but the set is having 5 different items. So here 5 item set means what? It is having 5 different items, say A, B, C, D, E. You can consider A can be bread, B can be butter, okay, C can be uh, egg, C can be egg, less on, okay, like this. So here when we take 2 to the power of D, okay, it is nothing but 2 to the power of 5. Here 5 items are there. So if you consider whole lattice, if you count this whole lattice, for only 5 items, we have 32, okay, including this and including null. We have 32, okay, candidates. Is it clear for you? Okay, we have 32 candidates. This is one candidate, this is one candidate, this is one candidate. Okay, so what is what was done in the brute force approach means, okay, all the candidates, okay, entire candidates were considered. Okay, all the candidates were considered. Each time the entire database was was scanned. Okay, entire database was scanned. Okay, and the support of each candidate, or the frequency or the occurrences of each candidates were taken into consideration. Okay, so you can, in the brute force approach, what was done in the brute force approach, if there is d item, there is a 2 to power of d candidate. Okay, so entire candidate, okay, 2 to the power of d, entire candidate set was scanned. Okay, and to find the support of each candidate. Okay, what was happening every time the database was scanned for the all the candidates. So what was the result? The result was it was computationally high. Okay, so the time complexity was more and the space complexity was also more, and expensive because, and this approach was expensive because here the number of candidate was is equal to 2 to power of t. Okay, this is m means number of candidate, n means number of transaction, and w means it is the average length of the item set. Okay, average length of the item set. Since the lattice, since in this approach, okay, every time the entire database was scanned, okay, the time complexity and the space complexity was more. So to overcome this, okay, we to overcome this, two people worked on it and came with one good algorithm which became most popular. That algorithm is called a priori algorithm. Okay, so what is basic focus of this a priori algorithm? To reduce the number of candidates. Okay, how to reduce the number of candidates? As I shown in the previous slide, so in the two-step approach, first step is frequent item set generation, second step is rule generation. As I mentioned here, out of this two, the first step is more expensive. Why? Because in the brute force approach, the entire data set used to scan for every step. Okay, so that was expensive because it used to consider every candidate, okay, which is frequent or infrequent. Okay, that's why it was becoming expensive. So in the a priori principle, it is mainly a priori algorithm. It is mainly focused on reducing number of candidates. Okay, instead of taking 2 to the power of d candidates, or 2 to the power of 5 means 32 candidates, which is infrequent, we can just reduce it. Okay, so here to start with, what is a priori algorithm? A priori algorithm is given by two persons, that is R. Agrawal and R. Srikanth in 1994 for finding frequent item set in a data set. Okay. Why the name a priori? Okay, why the name a priori? Name of the algorithm is a priori because it uses prior knowledge, okay, of frequent item set properties. Okay, once again I tell why the name a priori, because it uses prior knowledge of frequent item set properties. Here in this a priori algorithm, we apply an iterative approach or level-wise search where k frequent item set are used to find k plus 1 item set. In the coming slides, I will show you. So to improve the efficiency of level-wise generation of frequent item set, an important property or a principle, okay, is used that we called as a priori property or a priori principle, which helps by reducing the search space. Okay, which helps by reducing the search space, as I was telling in the previous slide. So it in the a priori property, okay, using the a priori property, we no need to scan the entire database every time. Okay, that is the main agenda here. Okay, our focus here. So here a priori property helps by reducing the search space. What is this a priori property? The a priori principle or a property is nothing but it states that, okay, this is very, very important. You should remember this. A priori property states that if an item set is frequent, then all of its subsets must also be frequent. Item set is frequent, its subset frequent. Conversely, if an item set is infrequent, its supersets, okay, please note here, its supersets must be infrequent too. So I repeat once again, item set is frequent, its subsets frequent. Item set is infrequent, its superset infrequent. Okay, this is the a priori principle or a priori property which is given by the two person Agrawal and Srikanth in 1994. Okay, so what is actually a priori principle holds? Okay, a priori principle holds due to the following property of support measure. Okay, what that it means? Okay, for all x, y. What is x? X is one item set, y is another item set. Okay, so if x is a subset of y, okay, if x is a subset of y, then, okay, support of x is greater than or equal to support of y. Okay, here we can say y is superset and x is subset. So if you observe this property, okay, it says that support of an item never exceed the support of subset. I told x is a subset and y is a superset. So support of an item, that is y, never exceeds the support of its subsets. This property we call it as anti-monotone. Okay, remember the name anti-monotone property of support. This property we call it as a anti-monotone property of support. Let us see with an example how actually it works. So what is a priori principle? It says if an item set is frequent, then all of its subset must also be frequent. Okay. Conversely, what I told, if an, yeah, here first I'll show you. Yeah, how we can say if the item set is frequent, let us say AB is a frequent item set. Frequent item set in the sense what? AB, if the customer purchase A, okay, the customer also, most of the customer, okay, most of the customer who purchases A also purchases the item B. So AB goes together. Okay, so we can say if AB is a frequent item set, then the subset of AB, what is the subset of AB? A and B. So they are also frequent. Suppose if we take another converse statement, so the item set is infrequent. Let us consider AC is a infrequent item set. What do you mean by AC? Infrequent. That means this there is no much correlation. There is no correlation among these items. Okay. If the customer purchases A, then very rare the customer also purchase C. Okay. That means the minimum support, that support of this AC will be less than the minimum support. Okay. So here, when we consider infrequent, what should we look for? We always has to look for superset, not the subset, superset. Okay. So must be infrequent also. What are the superset of AC? Okay, which contains the AC. Here we have AC, then here we have AC, here we have AC. Rest of the things we don't know. We don't have. So here we have AC, here we have AC. So here also we have AC. So here, what are the superset of AC? Here. Okay, this also we called as an infrequent. Okay, it is direct superset. So what we can do here, why this statement is done? In a priori algorithm, we have two steps. One is joining, another is pruning. Okay, what is this pruning? Pruning is nothing but we are eliminating the infrequent item set from the database. Okay, when the items is not going together, then there is no meaning in keeping it, okay, and scanning the database. Okay, so keeping it in the database and every time scanning it. So that is the main idea here, that the item set which is infrequent, okay, then the superset of that item set, okay, that means the baskets which contains this item, infrequent item set, can also be eliminated, will not be considered, okay, will not be considered for the candidate generation. So here, so that step we call eliminating the infrequent item set from the database. We call that step as pruning. So when we do the pruning, okay, when we do the pruning, so in the previous example I gave AB as a frequent. Suppose here AB is a infrequent. Okay, AB is a infrequent. We'll consider all the superset of AB, ABC, ABD, ABE, ABCD, ABCE, ABDE, ABCD. So entire superset we'll consider, and what we'll do, we will prune the superset. So when we prune the superset, what happens? This many number of items it is eliminated from the database. So here 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. Okay, out of 32, 8 item set has been eliminated. So we have left with only 24. So for next scan, we have to scan only 24 item set, not the 32. This was the limitation in the brute force approach, that is naive algorithm. That means every time they used to scan 32 item set, every time. So that's why the space complexity was more. Okay, so here what we are doing, we are finding using the a priori property. Okay, a priori property. So we are finding the infrequent item set and the superset of that infrequent item set, and entire thing will be eliminated, so that each time when we scan the database, the size of the database will be decreased. Okay, so the time complexity and the space complexity will be good. Hope it is clear for you. Okay, next we move on to the method, how actually it is used to find the candidate generation. Okay, so in the a priori algorithm, first we'll scan the database once to get the frequent one item set. When I say one item set, the item set will be having only one item in it. Okay, then what we do, we generate the length k plus 1 candidate items from length k frequent item set. We keep on increasing. So we candidate means we use the term C here. Okay, C. First one item set, so C1. Then we go for a combination of two item set, that is k plus 1. Okay, so test the candidate against database. Okay, that means we will find the support of each candidate, and we'll check. Okay, we'll check for is there any candidate which is having less than the minimum support threshold. Then if it is having, we will just terminate, okay, the infrequent candidate or item set from the database. This is our main focus here. So let us take an example of his. This I have told you before also. So we'll revisit before going to little bit complex example. So here we have this many transactions. The transaction, that when I say transaction, this is one customer basket. Okay, this is one customer basket. So customer one will be would have purchased this. Customer 2 would have purchased this. Customer 3 would have purchased this. Customer 3 would have purchased this. And customer 4 would have purchased this. So we have in each basket, we have the transaction like this. Okay. Just a minute. Okay. Let us take this as an example, and let us take the minimum support given is 2. Okay, minimum support is 2. So what we do according to the method, first we will scan according to the method. First we will scan the database for the one item set. Then we keep on incrementing the item set. So first we say that as a candidate C1. So how many items, how many different items are here? A, B, C, D, E. So all the item set, one item set, C1. One is means one item set. All the item set will take, and we'll scan the database to find the support of that item set. What do you mean by support? It is very, very simple. It is nothing but the support count. Actually, two things I told you in the last class: support count and support. What is support? Number of uh, occurrences. Okay, number of occurrences of that particular item in the database. So how many times A is occurring? 1, 2. Here 2. How many times B is occurring? 1, 2, 3. 3. Okay. How many times C is occurring? C. Okay. So we will find each item support count, and we'll check each item support count against the minimum support. Is there any item which is having less than frequent item set? Less than minimum support threshold. So here all have greater than equal to. Okay, it should be greater than equal to. 2 is equal, 3 is greater, 3 is greater, but 1 is less. Okay, E is greater. So which is infrequent here? D. So we will eliminate. Okay, we'll eliminate D from the database, and we keep only the frequent item, that is A, B, C, and E. That's what we call it as L1. L1 is nothing but frequent. Then we move to, similarly, we go for now it is a single item set. We go for which are the items which go together. So we do the combination AB, okay, AB, AC, AE, BC, BE, and CE. Like this, we do the combination. Then again, against the original database, we find the support count of each two item set that we called as a C2. Okay, when we see this, we have to check which are the two item set which is having less than minimum support. So here AB is minimum support, that means they are not frequently purchased, and A is minimum support. So this two we will eliminate, okay, from the candidate generation. Then we'll consider only AC, BC, BE, CE. Okay, so you can just imagine that in lattice, okay, we have all this. Okay, from the lattice we are eliminating all this. Okay, from the lattice we are eliminating. Original database will be there for further analysis. So from the lattice that means we are just reducing the scanning of number of candidates. Clear? So we are eliminated, we consider only this much. Then we go for the combination of three. So AC, BC means A, B, C, and B, E, B, C, B, C, E. Then B, C, E, it's already there. Okay, then we'll find the BC will get, then we'll scan the database for the support code, we'll get 2. So this is the frequent item set. Okay, 3 frequent item set. This will get as a BCE as a frequent item set. Okay, so this is about the simple example how the a priori algorithm works. So what we have to focus in this simple example, why I have taken this simple example to make you understand that in a priori algorithm there is two step. Okay, in a priori algorithm there is two step. First step is join. Okay, join. Second step is prune. I told prune. Prune, when we use this step, it is basically used when we go for a 3 item set. Okay. When this pruning will done, the pruning will be done when the subset of a item set is infrequent. Okay. This is basically for infrequent item set. Okay, so what is this join and prune? Here, what we are doing for the candidate item set, one item set, we are just scanning and we are finding the support and we are comparing with the minimum support and we are taking. The next step, okay, do you remember I told it is an iterative approach, okay, a priori algorithm, okay, it is an iterative approach and level wise candidate generation, level wise. So level 1, level 2, level 3, like this level wise candidate generation algorithm it is. Okay, so what we are doing here, we are doing the this one joining. Okay, here we are doing the joining, that is first step. How this joining has come, we are using the frequent item set. We are joining the frequent item set L1 into L1. We are joining L1 into L1, joining. When the pruning will comes, when we go for the item set 3, more than 2 item set. So here we got A, C, B, A, B, C. Okay, A, B, C. Here when we came here, when we are converting to this, okay, there was also one more item set of 3. Okay, that is A, B, C. Okay, A, B, C. Then we got B, C, E. 2 item set of size 3 we got. But here only B, C we consider. We are not considered A, B, C. Why? 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 Because what are the subset of this A, B, C? The subset of ABC is AB and AC. AB and AC. Yes or no? Subset of A, B, C are A, B and AC. So when we look into the frequent item set of L2, there is no AB. Do you see here there is any AB here? No. AB is not a frequent item set. Do you remember? AB is not a frequent item, but AC is a frequent. But what the second statement says that if any item set is infrequent, the superset is also infrequent. Is it clear? Okay. If any item set is infrequent, the superset is also infrequent. That's why it is not considered in the C3. Okay. Only BCE consider. When we take BCE, what are the subset of BCE? We have BC and CE. So BC is also there, CE is also there. So we'll take, means all the subset of BC is frequent. So obviously BC is also frequent. That's why we are taken. And after considering this, we'll check for the support count. Yeah, it is having the support count equal to minimum support. Yes or no? Minimum support. So it is a frequent item set we are considering. So pruning. Pruning means what? So out of ABC and BCE, okay, we found that ABC is infrequent. So we pruned it. Okay, we pruned it. Clear? We consider only BCE. Okay. So this is what, these are the two things we will do in the a priori algorithm. This pruning actually eliminate the infrequent data so that the candidates will be reduced. Okay. So next we move on to the algorithm. So the pseudocode of a priori algorithm. So I think by this time you have got some idea how we do the algorithm. That's why I took the simple example. Later I came to the pseudocode. So CK, we have two terms here. CK, candidate item set of size K. Candidate item set. What is candidate item set? When we scan the database, what the candidate will get, okay, that we called as a candidate item set, which we use the term C. What is K? K is nothing but item. Okay, 1. K is equal to 1 means 1 item set. K is equal to 2 means 2 item set. K is equal to 3 means 3 item set. When I say 3 item set, the item set will be having a collection of 3 different items. Okay, so what is LK? LK is the term used for frequent item set of size K. Frequent item set. When we say frequent item set, it is nothing but when we say frequent item set, what is that frequent item set? Always the support of that item set should be greater than or equal to minimum support. Okay, it should be greater than or equal to minimum support. Is it clear? Okay, then that is only the frequent items. So what we'll do here, let us first, we'll find the L1 is equal to frequent items. It means we'll scan the database and we find out the support count of each items in a database. As I told, A, B, C. What we are doing here, we are finding the support count of each. This is nothing but the first step, what I am showing here, L1. L1 is equal to frequent item set. This one. Okay, followed by this. So first step is we will find the L1, the support of each item set, and check against the minimum support. Okay, so we'll find the L1. This one, L1. Then what we'll do, I told it is an iterative, okay, iterative process. So that's why loop. For K is equal to 1, LK is not equal to null. That means what? No further frequent item. Okay, L1 is the last, or it can be L2, it can be the last, L3 can be the last. Okay, so L3 means what? It will be having 3 item set. Three item set means what? We should not consider 3 different means 3 item set means here it is of this form. like this. A, B, C. Okay, like this. We'll be having item set. Means this is one item set. This we call it as a 3 item set because it is having this 3 different items. Similarly, there can be a number of 3 item set. So k is equal to 1, lk not equal to null. That means the upper limit of k, that is lk, l3, l4. Okay, so k is equal to 1, l1 is not equal to null. Okay, L1 is not equal to null. Then what we have to do, Ck plus 1 is equal to candidate generation from Lk. Okay, so what we are doing here, we are just, so first we found out this. Next what we are doing, we are finding the C2. What is this C2? Where K is equal to 1. K is equal to 1. So K plus 1. K plus 1 will become K plus 1 will become 1 plus 1, that is C2. We'll generate the C2 and we'll take the support count and we check against the original database. If the support count is less than the minimum support, we eliminate this. So we'll generate the candidate generated from LK. Okay, LK means L1 here because K is equal to 1. For each transaction, what we'll do, increment the count of all candidates in CK plus 1 that are contained in T. Okay, then LK plus 1 is equal to candidate in CK plus 1 with minimum support. So this is what here. Okay, we'll found L1. From L1, we'll do L1 into L1, that is we are joining L1 into L1, that we will get this. And what we are do, we'll scan the database and find the minimum, find the support count of each item set. Okay, 2 item set, that is C2. Then we'll check is there any infrequent item which is having less than minimum support. So this is L2. So L2 into L2, we go for C3. So we eliminate the infrequent and we'll get the L3. That is what actually we are doing in the algorithm. Finally, we return the LK, okay, highest LK. So when we stop this, there will be a level where we don't get further frequent items. It may stop at 3, okay. It may not have 4 frequent items, okay. 4 item set frequent item set. So there we will start till the LK is not equal to null. We keep on doing this iteration. Once LK becomes null, we stop there. Okay, so we'll see a bigger example, okay, that makes you more clear, okay, about this a priori algorithm. Okay, just a minute, I'll just clear this drawings whatever I done. Okay, so I want you to concentrate on this example. We'll discuss in detail this example. So consider the database D. This is the transaction database. This is the transaction database consisting of how many? 9 transactions. Here minimum support is given as 2. If you want to convert into a percentage, you can do 22%. Suppose they are given you 20%. Minimum support is say 20%. Okay, how you will convert into the number means 20 divided by 100 . Sorry, it looks like, it doesn't looks like 100. Okay, into 9. Okay, this will be the method to convert the percentage of percentage into a number. Okay, if it is coming 2.9, then you can convert into a 3. 3 will be your minimum support. If it is 2.4, you can just consider as 2 only. So 2 will be your minimum support. Is it clear? Okay, so here they are directly given the number, no issues. Okay, directly given the number. Suppose if they are given the percentage, okay, 30%. Okay, 30%. 30 divided by 100 into 9. Like that you can convert. And here the confidence is given as 70%. Remember, minimum support is 2 and the confidence is 70%. What are these? These are the metrics. Yes or no? Metrics. So to find the frequent item set, always remember to find the frequent item set, we use the metric called support count. Okay, against the minimum support count. And to find the or to generate the association rule, we always use the confidence against the minimum confidence. Two metrics. Okay, to generate the frequent item set, we need only support. To generate the rules, we need confidence. Clear? So, what we have to find in the a priori algorithm? Two things. First, we have to find the frequent item set. Then we have to do the association rule generation using minimum support and minimum confidence. Hope it is clear for you now. So we can have a look into it. You can write down this. Okay, shall we move? So what is the first step in the a priori algorithm? What is the first step in the first a priori algorithm? We have to scan the database and we have to find one item set. Yes or no? K is equal to 1. And we have to come up with a frequent item set, that is L1. Okay, L1. So what we do first, this is a original transaction database D. What we do, we scan D for count of each candidate. So how many different candidates are there? I1, I2, I3, I4, I5. So 5 different items are there. So as I told, these are the transaction, okay, done by the customers, different customers. So what we'll do, first we scan and count the occurrence of or count the support count of each items. So I1, I2, I3, I4, I5. Then how many times I1 is occurring? You can see 1, I1 is 1, 2, 3, 4, 5, 6. So 6. So support count is 6. Similarly, I2, I3, I4, I5 will be counted. Okay. Next, what you have to find, this is the candidate. Uh, these are the candidates. So what we have to do next, we have to find the frequent item set. Candidate item set. This is, we have to find frequent item set. How we can find the frequent item set? By comparing the candidate support with the minimum support count. What is the minimum support count given? You remember? Minimum support count is how much? In the question it was given, it is 2. So minimum support is 2. Minimum support is 2. We have to check, is there any item set which is less than 2? No, all are above 2 only. Yes or no? So what will be there in the frequent item set? All these 5 items will be there. I1, I2, I3, I4, I5. You got to know, here nothing is pruned out or terminated because all are having more than minimum support. So everything will be considered. This is L1. Please remember what is L1. Okay, L1 is the frequent item set. C1 is a candidate item set. They are the candidates. Okay, the candidate item set are the item set which will be having frequent and infrequent item set. Okay, so then we will filter the infrequent item set and we'll get only the frequent item set L1. Okay, L1 will get. Okay, so L1 is a frequent item set which is having the items which is whose support count is more than the minimum support count. Hope it is clear for you. Okay, what is the next step we have to go for? Once we have got the L1, okay, we have to do the start the iteration. So we have to find the next level, that is k c k plus 1. Here k is equal to 1. C of k plus 1. K plus 1 means what? 1 plus 1. So we have to find the candidate item set of size 2. Okay, of size 2. So for that, what we have to do? We have to apply a join operation for L1 with the L1. L1 into L1 we have to do. That we see in the next. This is the explanation, whatever I just told you. So we'll see this one. We have to apply the join operation. L1 into L1. So if you observe this, okay, arrow mark, what I'm doing, I1 is not taken. If you see, there is no arrow going to I1. I1 into I1 is nothing but I1 only. It comes as a one item only. I1 and I1, I cannot say it is two different items. Bread is bread only. Okay. The count may be two, but the bread item is one item only. It comes to one item. So that's why we just ignore I1, I1. So we combine with a different item. Okay, bread with jam, like that. So I1, I2, I1, I3, I1, I4, I1, I5. So here you can see here the count is there. And that's item set is there. This we called as C2. Why I am telling C2? Because C2 is a candidate item set which is having two items, two different items. Is it clear? C2 is a candidate item set which is having two different items. So if you see this one, I5, it is in black color, so it will be more clear for you. So I5 is combined with I1. So you can say I1, I5 or I5, I1, it is one and the same. So it is only one occurrence. So I1, I5, I2. I5, I2 we have here. I5, I3. I5, I3 we have here. And I5, I4. I5, I4, I4, I5 is one and the same. So we can keep it like this. Okay. So this are the seed we are combining. Okay. Next, what we have to do? We have to scan the database and find the support count of this item. We have to find the support count of this item. Okay. That we'll see. So this is the original database. Okay. So we have got C2 like this. So let us take I1, I2. So I1, I2 combination, where and all it is occurring. I1, I2. In the transaction 1, the customer has purchased I1 and I2 both. Here, no. Here we have the customer in the transaction T4. The different customer also purchased customer A, customer B. Customer B also purchased I1 and I2. Here I1, yeah, here also I1 and I2 is there. Customer X has purchased I1 and I2. Customer Y also have purchased I1 and I2. So how many count is there? 1, 2, 3, 4. So 4 count is there. So here you can see it is 4. Similarly, we will find the frequency or occurrence of this two item set from the original database. So what we'll get? We'll get like this. I1, I3, 4, I1, I4, 1, I1, I5, 2, I2, I3, 4, I2, I4, 2 times it is occurring. I2, I5 is also 2 times occurring. I3, I4, no transaction. I3, I4, they are not purchased. Any of the customer has not purchased. So 0. I3, I4, one customer has purchased. I3, I4. Okay. Sorry, I3, I4, nobody has purchased. I3, I5. I3, I5, yeah, here it is. I3, I5, it is 1. I4, I5, 1. Okay. I4, I4, I5 is also, it looks like 14, 15. It is actually I4, item 4, item 5. Okay. Item 4, item 5. Item 4, item 5, nobody has purchased. So it is 0. Okay. This is the actual count from the original database. Okay. Now then what we have to do? We have to find the L2, frequent item set. What is frequent item set? to tell that item set is a frequent item set, it should have the support more than or equal to minimum support. What is the minimum support we have? 2. Yes or no? So we'll take the items which is having equal to or more than 2. This is more than 2. This is more than 2. This will not consider. Okay, this will not consider. This will consider because equals. This will consider it is equal. It is also equal. It is also equal. Rest of the things we will take it off. Okay, we'll prune out or terminate because they are not equal or they are less than 2. So I1, I2, yes, it is there. I1, I3, yes, it is there. I1, I5, yes, it is there. Then I2, I3, yes, it is there. I2, I4, yes, it is there. I2, I5, yes, it is there. Okay. So out of how many item set, candidate item set, we have got the frequent item set. So here totally how many were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10, we have got only 6. 4 is pruned out. Yes or no? So we have got L2. Okay. So what we are, we have to inference from this that we have reduced the candidate items. Okay, we have reduced the candidate items. So the space is getting reduced. Is it clear that L2 we have got the L2? Okay, next what we have to do? We have to take L2. Okay, we have to take L2. L2 into L2 we have to join and we have to find C3. Okay, we have to find C3. So C3 will take. Okay, so L2 into L2. Okay, L2 into L2. As I showed you in the previous things, like L1 and L1 we combined, we got this C2. Similarly, L2 and L2. Okay, this one. Okay, not this one. This is not frequent. So L2 and L2 will combine in this form. Okay, in this form. Then we will get the C3 like this. C3 having I1, I2, I3. So if you observe in the previous L1 and L2, we didn't apply any a priori property. What is this a priori property? If the item is frequent, then the subset is also frequent. And the item is infrequent, the superset is also infrequent. We didn't apply any a priori algorithm here. Sorry, a priori property here. So here we will be going to apply the a priori property. So we got the candidate of item set three item set like this. Okay, by joining L2 and L2. Okay, so but after counting the support, we have got this. So we are applied here a priori property here. Okay, we are taken the support count here. Then the L3 is here. How this C3 has become only 2 set here. Here we have 6 different item set, but we have come up with only 2 here. How it is? I'll show in the next slide. Okay. Okay. So please concentrate here. We are talking about the pruning step. Okay. So here we have join C3. Okay. We are applying the join operation L2 into L2. So L2 into L2. When we apply L2 into L2, okay, we'll get the candidate C3 like this. Okay. So I1, I2 into I1, I3. Okay. So we'll get L2 and L. Just a minute. Just a minute. Okay. Now let us consider the how to find the candidate 3, C3. Okay, item set. So how we'll get by joining L2 and L2. So by joining L2 and L2, we will be resulted with this item sets, C3 item set. You can see here by joining this I1, I2, I1, I3, combine the same L2 is joined with the L2 set only. We will be getting the 6 different 3 item sets. That's what here I have written. Okay, shown. So now what we have to do here? Here actually we have to apply the a priori property. Okay, how we can do that? So prune using the a priori property. All non-empty subsets, okay, of a frequent item set must also be frequent. So do any candidates have the subset that is not frequent? We have to check. Okay, so the two item subset of I1, I2, I3. So let us take first one I1, I2, I3. So here I1, I2, I3 we have taken. So what are the subset of I1 and I2? I1, I2, I3, that is I1, I2, I1, I3, I2, I3. Okay, I2, I3. So we have to check whether all these three items, okay, whether all these three items are there. Okay, all these three items are there in this L2. Okay, so I1, I2 is there? Yes, it is there. I1, I3 is there? Yes, it is there. I2, I3 is there? Yes, it is there. All the subsets are present, then automatically I1, I2, I3, this candidate is also frequent. So all these three are the members of L2. So therefore, I1, I2, I3 can be there in the C3. Okay, next we have this one. So next we'll take the I1, I2, I3. Second one, I2, I1, I2, I5. I1, I2, I5. What are the subset of I1, I2, I5? I1, I2, I1, I5, I2, I5. Okay, so these are the subset. What we have to do that? Then we have to check in the L2. So I1, I2, yes, it is there. I1, I5, yes, it is there. I2, I5, yes, it is there. Then all three item set is there in the L2 frequent item. They are frequent. So we can consider I2, I1, I2, I5 in the C3. So this is also can be considered. Okay, next. Next we'll take the next item set I1, I3, I5. I1, I3, I5. What are the subset of I1, I3, I5? I1, I3. Okay, then I1, I5 and I3, I5. We have to check whether all these three are there in the L2. So I1, I3 is there? Yes, it is there. I1, I5 is there? Yes, it is there. But I3, I5, I3, I5 is not there. Okay, this is not there in the L2. Okay, this subset is not there in the L2. So according to the a priori property, if this the item set is not frequent, the superset is also not frequent. So we will not consider I1, I3, I5 as a candidate of 3. Okay, this will not be considered. Similarly, we will take I2, I3, I4. What are the subset of I2, I3, I4? I1, I2, I2, I3, I2, I4, I3, I4. Okay, so here again I3, I4 is not present in the L2. I3, I4 is not present. So this is also will not be pruned. It is also will not be considered. That means it will pruned out. So this is also not there. Then next we'll take I2, I3, I5. So what are the subsets? I2, I3, I2, I5, I3, I5. Okay. So out of this, again I3, I5 is not there in the I3, I5 is not there in the L2. So this three items that will also be not considered. Finally we have I2, I4, I5. Okay, I2, I4, I5. So what are the subset of this I2, I4, I5? I2, I4, I2, I5, I4, I5. Okay, I4, I5 is not there in the L2. Okay, so I4, I5 is not the member of L2. That means it is infrequent. So automatically I2, I4, I5 will be pruned from the C3. So out of 6, okay, 4 is pruned. Okay, 4 is pruned and we have got with only 2. Okay, so this is what I showed you. Okay, this is what I showed you in the previous slide. So we have got 6, but applying the a priori property, we have reduced the C3 only for Okay, so we will find the support count of this. So to find the support count of this, when we find the support count of this from the original database, we will be getting 2, 2. That means what? These are the two frequent item set we have got from the database. That means these are the two frequently purchased items by the customers. Okay, so next we will move on to another. We'll combine these two. We'll join L3 and L3. Okay, when we join L3 and L3, okay, when we join L3 with L3, okay, what we will get? I1, I2, I3, I1, I2, I5. So when we join, what are the different items we'll get? I1, I2. So please bear with my writing. I3 and I5 will result in I5. Okay, we'll get this. So this we have to check in the count database. Before that, we have to find out, is there any subset which is infrequent? I1, I2, I3. I1, I2, I3 is frequent. I2, I3, I5. There is no subset item I2, I5, I3 in the C3. Yes or no? You agree with me? If you consider I2, I3, I4, I2, I3, I5, sorry, I2, I3, I5 is a subset of I1, I2, I3, I5. So I1, I2 are subset. But the subset is not found in this L3. I2, I3, I5 subset is not there in the L3. That means it is infrequent. Then if it is infrequent, this entire set is also infrequent. So what we'll conclude that C4. C4 means what? 4 item set. 4 item set is null. Okay, is null. So that means what? When it is null, we have to stop here. Okay, what the algorithm says, we have to stop. Okay, when the condition is LK is null, okay, we have to stop the iteration. So we will stop here. Okay, C4 is null, we'll stop here. So final item set we will be having L3. Okay, that's what it is told here. So final item set, thus C4 is null. The algorithm terminates having found all of the frequent items. So this completes our a priori algorithm. So what we have to find next? We have to find the strong association rule. So you have to remember what is the frequent item set we have? I1, I2, I3, I1, I2, I5. These are the frequent item set we have now currently. Okay, these are the frequent item set. So what next? First step is over. We have generated frequent item set I1, I2, I3, I1, I2, I5. Two frequent item set we have generated. So we have to move on to next step, that is rule generation. So rule generation says that for each frequent item set I, generate all non-empty subset of I. Okay, we have to generate the non-empty subset of I. For every non-empty subset S of I, output the rule S tends to L S if support count of I is divided by support count of S greater than equal to minimum confidence. Okay, where minimum confidence is minimum confidence threshold. That here we have to consider the minimum confidence. What is the minimum confidence given? It is 70%. Okay, 70%. So here we'll take what are the frequent items that we have got? I2, I1, I2, I3 and I1, I2, I5. So we have to consider all the subset of this I1, I2, I3 and I1, I2, I5. So when we take, we'll get I1, I2, I3, actually I5. Okay, we'll I1, yeah, we have I1, I2, I3, I4, I5, I1, I2, I3, I1, I3, I1, I5, I1, I3, I2, I4, I2, I5, I1, I2, I3, I1, I2, I5. So here we'll get the subset. Okay. So when we take, we have pruned out the I4 and all, I4, I2, I4, they are infrequent. It will not come. So let's take I1, I2, I5. So out of this frequent item set, we have considered the subset also. We'll take, what are the subset of I1, I2, I5? I1, I2, I1, I5, I2, I5, I1, I2, I5. We consider this. So here what we have taken, how we are taken. So we have got L1, I1, I2, I3, I4, I5. This one, then this one, I2, I3, I3, I1, I3, I1, I5, I2, I3, I2, I4, I2, I5. This one, L2 and L3, I1, I2, I3, I1, I2, I5. Okay, this we called as a frequent item set. That's what here it is given. Okay, L1, L2, L3. So to find the rules, we'll take first the 3 item set. Okay, latest frequent item set, I1, I2, I5. So what are the subset of this? I1, I2, I1, I5, I2, I5, I1, I2, I5. So how to find the rules? Let us say rule 1. Okay, rule 1. So I1, I2, if the customer purchase I1 and I2, he may also purchase I5. So we will consider the confidence. What is the formula of confidence? Support of I1, I2, I5 divided by support of I1, I2. Okay, support of I1, I2, I5 whole divided by support of I1, I2. From the database, we'll get the support of I1, I2, I5 is what? 2. You can see here. It is 2. I1, I2, I5 is 2. Okay. Then support of I1, I2, it is 4. Okay. It is 4. That's why what we will do, 2 divided by 4, that is equal to 50%. Hope you are understanding how we will find the confidence. Confidence is this formula. Okay. Confidence is this formula, that is support count of I, okay, divided by, okay, support count of S. Okay, so like this, L minus S, L minus S. So I'll show you. This is a rule. Okay, this is a rule we are giving like this. Rule 1. If suppose we have a rule like this, if if okay, if 1, I just take item 1, item 2, then item 5. Okay, then the item 5. If this is the rule, then how I'll represent 1, 2 tends to 5. 1, 2 tends to 5. So how I can find the confidence of this? So support of all 3 LHS and RHS. 1, 2, 5. whole divided by support of one two only LHS. Okay, support of 1 2 like this we have to take. What is the support of 1 2 5? It is 2. What is the support of 1 2? It is 4. So what will get? We'll get the 50%. Okay, into 100. So when we do this, we'll get the 50%. But what is the confidence given? Minimum confidence, confidence 70%. But it is less than minimum confidence. So this rule will be rejected. Then what we have? I1, I5. Okay, next we'll take I1, I5, the combination I1, I5, I1, I2, I5. So next we'll take I1, I5 combination, which will lead to I2. So again, we'll consider it is 100% when we using the formula when we do this. So we'll 100%. That means this combination this is the rule. That means if the customer purchase I1 and I5, the customer also purchase I2 like this. So this rule is selected. Okay, this is there, but this is rejected. If the customer purchase I1 and I2, they may not purchase always I5. So next we have I2, I5, I1. This combination among that I1, I2, I5 only we have to take the combinations. So I2, I5 tends to I1. So we'll find the confidence. So we'll get 100%. So this rule is also considered. So what we are doing in the LHS 2 items we have taken. Now we'll reverse it. We'll take if the customer purchase I5, is the chance that customers also purchase I2, I5? Like that we'll see. Okay, all possible rules will make. So here now I have taken I1. If the customers purchase I1, there is a chance that I2 and I5 is there. We'll check. So we'll use the confidence formula and 2 by 6 we'll get 33%. So it is not considered. Okay. Then so it is rejected. Then we'll take I2 tends to I1, I5. So here 29% rejected. I5, I1, I5, I1, I2. If the customer purchase I5, he or she may also purchase I1, I2. So 100%. So this is selected. Okay. So how many rules we have got now? How many rules we have got now? We have got 3 rules that I1, I5 tends to I2, I2, I5 tends to I1, and I5 tends to I1, I2. These are the rules. Remaining things are been rejected. Okay. So this is how we do the a priori algorithm. Okay, first we have found the frequent item set. Then we have find the association rule. To find the association rule, we use minimum confidence criteria. Okay, like this. So here is one more example that you can work out. Please take down this. You work out. And in the next class, you tell me what is the frequent item sets and the association rule. Okay, in the next class you tell me. Okay, hope you have taken down this. In the next class we'll discuss you solve and come and we'll discuss the solution. Thank you.